Hello everyone. So today I'm going to discuss the Leetcode problem number 62, which is unique path. Unique paths. So you need to, in this problem, you are given a grid and you are given the size of a grid, which is m cross n grid. So the grid has m rows and n columns, okay? And you need to count the number of unique paths from this start position to this end position, okay? So if we look at this grid, okay, the number and the condition is you can only move right and you can move down. You cannot move left or you cannot move up. So you cannot do this, okay? You are only allowed to move this in this direction. So this problem is a DP problem, dynamic programming problem. So whenever you have a dynamic programming problem, you need to first come up with a recursive formulation, the recursive formula for that problem, okay? So if we look at this grid, how many unique paths it has? So you go right, right, and this. So that's one path. Another path is you go this way, right? Another path is you go this, and this, right? So, and another path is you go like this, and this. So whenever we are given m cross n grid, how many unique paths are there? Okay, so if you look here, okay, the grid is starting from 0 0 and you need to, this is your destination, which is m minus 1 and n minus 1, okay? So in any unique path, in any path, how many moves we are making? So if you look at this path, this one, right, how many moves are we making? So if you start from here, we are going all the way to right, so we are making n minus 1 moves, and then we are going down, which is m minus 1. So in any path, if you take this path or if you take this path, the total number of moves that we are making, total number of moves in a single path, okay, in any path, in any unique path is equal to m minus 1, which is downward, plus n minus 1, which is right, which is equal to m plus n minus 2. So those are the unique moves that we are making. Now how can we find how many number of unique paths we have, right? So if you remember, right, if I am giving you n students and I ask you that how many ways you can choose k students from the given n students, right? What is that? It is n c k, that is n choose k. You can also write it this way, right? So and the formula for this one is n choose k is n factorial divide by n minus k factorial, okay? So now I'm telling you that you have this many moves, m plus n minus 2, and can you please tell me how many unique ways I can make a right move? So you'll say, okay, the unique ways to make a right move, the number of right moves are n minus 1, so it is this many ways you can make a right move, right? And the remaining are the left move. So this, the number of ways you can make right move will be equal to so let me show you this formula first. So this, the number of ways we can choose k students from n is equal to the number of ways we okay. So n choose k, the number of ways we choose k students from n student is equal to number of ways we don't choose, I mean we exclude n minus k student. So similar way, the number of ways we make right moves would be equal to the number of ways we don't make a right move and we are making a downward move. So this would be n minus k, so m plus n minus 2 minus n minus 1, which will be equal to m plus n minus 2 minus n plus 1, which will be equal to m plus this will cancel out, so minus 1, so it will be m minus 1. Okay, so whenever, so here we are given matrix of size that we are given. Okay, so here m is 3 and n is 4, right? So when I ask how many unique paths are there from top left to bottom right, so that would be number of moves, which is m plus n minus 2, and number of ways we can select, we can go downward or we can go right, so it could be any. So that would be m plus n, so 3 plus 4 minus 2, 3 minus 1, which is equal to 5 and 2, and that is n factorial divided by n minus k factorial into k factorial, which is equal to 5 factorial, 3 factorial into 2 factorial, 3 factorial times 2 factorial. So that would be equal to 2 times 3 times 4 times 5, 2 times 3 times 2, 3. So total 10 moves. Okay. So now we are given this grid. whose size is 3 by 4. Okay. Okay. And you need to find number of unique path. So if you look here at this grid, okay, so this is 0 0 and this is m minus 1. Okay, so for this cell, how many unique paths are there to reach this cell? It's only one, right? And for this cell, the unique path is also one, because from this cell we go right and we come here, so there is only one unique path. For this cell also, it's only one unique path. We start from this cell and we go down. For this cell also, there is only one unique path, because we can go right or down, so we go down 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 and we reach this cell. For this cell also, there is one unique path. For this cell also, there is one unique path. So now for this cell, how many unique paths do we have? So for this cell, we can come in this cell from top, or we can come from this left, right? So we can come from here and we can also come from here. So the number of unique path for this cell is, when you add the number of unique path from in this cell plus this cell, so that is the number of unique path for this cell, which is 2. And now for this cell, what is the number of unique path for this cell? So we can come in this cell from here and here. So number of unique path for this cell is 1, and for this cell is 2. So 2 plus 1 is 3. Right? Now let's take this cell. We can come here like this and like this, right? So that is 4. We add 3 plus 1, which is 4. Now number of unique path for this cell, 2 plus 1, which is 3, right? And for this cell, 3 plus 3, which is 6. And for the last cell, which is our answer, the number of unique path is 10. Okay. So if we do a recursive formulation, what is our base case? So this is our base case. Okay. So if m is equal to 0, so if it's a first column, or n is equal to 0, if it's the first row, then we return 1. Okay. Else we make a recursive call to, so for this cell, this is our final this is our cell n minus 1, n minus 1. So for this cell, I'm going to make a recursive call to this cell and this cell. So this cell, the value for this cell is m minus 2, n minus 1. The value for this cell is m minus 1 and n minus 2. So I'm going to return make a recursive call to f of m minus 2, n minus 1 plus f of m minus 1, n minus 2. Okay, so that is our recursive case. Now in this recursive case, right, so let's see, for this recursive case, the time complexity is O of, it's exponential, right? It's 2 raised to m plus n, right? Because the recursive tree, right, it will have two recursive call. So this will we will start from m minus 1, and then we'll go to this recursive call. This will have again two branches until we reach 0. So the height of this tree will be m plus n. And the space complexity is recursive call stack, because this goes in the stack, then we make a recursive call, this goes in the stack, then we again make a recursive call, it goes in the stack, again make a recursive call. So the space complexity is m plus n. Okay, so that is the recursive formulation. Now can we reduce this time complexity? Of course, we can reduce this time complexity using dynamic programming. So how can we do that? So for dynamic programming, we need to create a grid. So we need to create a 2D integer grid. Okay, the size of that grid would be m cross n, m times n. Okay, so that is the size of this grid. And what are we going to do is we're going to fill in the base case. So we are going to fill the first row and first column with all 1, right? And then for calculating the value for this cell, what we need is we need value from this cell and this cell. So what we can do is we can traverse the grid row by row this way. Okay, or you can also do column by column traversal. Okay, and so it will be something like this. We are going to take an integer grid dp, and the size of the grid will be m cross n. Okay, and then we're going to fill in the base case, and when we reach, now then we will start iteration from this cell. So we'll go row by row. So what is the dp of ij? Is equal to dp of, sorry, I minus 1 j plus, this is I, dp of I j minus 1. And once we are done filling this matrix, we will return dp of m minus 1 and minus 1. So we will return the value from this cell. So what is the time complexity of this one? So we are traversing this whole grid whose size is m times n. So the time complexity is O of mn, and the space complexity is the size of the grid, which is O of mn. Now the question is, can we reduce the space complexity? So here, to calculate the value of this cell, we need value from the previous row and the previous column. So what we can do is we can just have 2 rows instead of having the whole matrix, and we can store the value of ith row, then I plus 1 row here, and then when we calculate I plus 2 row, we store the value here, and then I plus 3 here. So we can just reuse the 2 rows again and again. The code will be little complex, but yeah, with this you can have 2 rows and solve it in using a space complexity of O(n). You can also use 2 columns instead of 2 rows because you need value from previous column and previous row. In that case, the space complexity will be O of m. So it depends. If you have too many rows, then you can go for this using 2 columns, and if you have too many columns, then you can go and use this, which is using 2 rows. Oh, sorry. If you have too many columns, then you can go with this, that you can use only 2 columns, okay, because you have too many of this n, right? So if n is greater than m, right, then you can use this, and if m is greater than n, then you can use this, okay. So that's one of the option for you to use. Now let's go ahead and write the code. So I will write the recursive solution first, and then I'm gonna write the DP solution, okay. So let me write the recursive solution first. Public, the return type is integer because we are returning the number of unique path. Count paths, integer m, integer n, okay. So for recursive solution, our base case is if m is equal to 0 or n is equal to 0, we will return else we are going to return count paths. So we need to calculate for m-1, n-1 cell. So the top cell would be m-2, n-1, and the left cell would be n-2, m-1, n-2, okay. So that is the recursive solution. And what is the time complexity of this solution? It's exponential, 2 raised to n plus n. And the space complexity is a stack trace recursive stack call stack, which is n plus n. The recursive call stack size is n plus n. And then what we are going to do, let's write the DP solution, okay. So public integer count paths, integer m, integer n. So in DP solution, what we need to do is we need to define initialize a 2D grid, which is our DP grid, and the size of that grid is m rows and n columns. And for this particular Leetcode version of the problem, if you are given a matrix of a very large size, then the number of paths may be very large, so you need to do a mod with 10 raised to 9, 10 raised to 9 plus 7 to get a right answer. So that's the integer max value. So you need to do mod with this one, your final answer, so that it doesn't run out of that integer overflow. So 1, 2, 3, 4, 5, 6, 7, 8, and this, okay. And then for we're gonna do row by row. So integer I is equal to 0, I less than how many rows we have m rows, I plus plus, for have n columns. Now what happens if it's the first row or the first column? So if I is equal to 0 or j is equal to 0, in that case we're gonna fill the cell with value 1, else we are going to fill the cell with whatever the recursive formula that we have, which is dp of ij is equal to dp of I minus 1 j plus dp of I j minus 1, and for the Leetcode problem don't forget to do mod of to get the right answers. So the whole answer we need to do modulo this mod value, and then okay, and what we are going to return, so we are going to return dp of m minus 1 n minus 1, and what is the time complexity for this solution? We are iterating the matrix or the grid. The space complexity is the size of the grid, but as I told you, we can reuse those. We only need 2 rows or 2 columns, so you can just keep reusing those, but you have to be careful where you are storing the rows and the columns. I mean, you need to do some calculation if you want to reuse and reduce the space complexity. So I think that's it for this problem, and let me know if you have any questions, and please subscribe to my channel. Thank you so much for watching.